Hello everyone, welcome to this English course. We are going to talk about digital communication. So first, let's talk about analogical data. Analogical data are physical measurements that are done with sensors. So I guess you know a lot of sensors. We can talk about a pulse sensor, a temperature sensor, a sound sensor, light sensor, or an accelerometer. Accelerometer is used to measure acceleration, velocity, and distance. Okay, so analogical data is everything that is around you that you can feel, that you can see. And then these analogical data are transferred into electrical signal through a code device that will transform the analogical data into digital or numerical data with 0 and 1. Why? Because in fact, the advantages are important. The numerical signal can be reduced, stored, copy-paste, transmitted easier than analogical data, but the quality is a little bit worse. It's not as perfect, it's not as good. By the way, a bit, 0 or 1, is a binary digit. Encore un acronyme anglais pour dire donc une donnée digitale, donnée numérique. Bit, binary digit. By the way, you see on the red the analogical signal, and on the green you see the numerical signal. So you see that the numerical signal is less precise. It doesn't fit 100% with the original data. So you can send this signal very far away on a satellite, for example, or you can send this numerical signal very close in a car, or you can use it also on a watch for the runner. Sensors. Sensors for the environment are various, and you will use it in your project. So if you want to see some nice video or more explanation, you can go on this link, click on this link, www.lafabriquediy.com, and you will have all the various sensors that you can use in your project. So for example, you have the flame sensor, altitude pressure sensor, sound sensor, infrared thermometer, RGB for red, green, blue sensor, photocell, moisture sensor, UV sensor, gas sensor, or thermistor, which is thermistance in French, which is used to measure temperature. Sensor for movement. You can measure also movement with accelerometer, bend or flex sensor, so that's a capteur de flexion pour les déformations mécaniques. A vibration sensor, obstacle sensor, piezo sensor, passive infrared sensor for movement, tilt sensor, line follow infrared, ultrasonic sensor. This one is very useful because it helps you to detect the distance from the sensor to an object. So it can be very useful in your project. Angle sensor, load cell, cellule de charge, which is used to measure the weight, pour mesurer le poids. Hall effect sensor. Hall effect sensor can detect magnetic field, and it's also very useful to measure, for instance, the velocity of a motor. Hein, on mesure la vitesse de rotation d'un moteur à courant continu avec des capteurs à effet Hall. Très utile. Camera thermique, thermal camera, infrared camera. So all these sensors are the other category of sensor, human interaction and various other one. RFID reader, fingerprint reader, empreinte digitale. Pulse sensor, so that's the same as you have in the watch for the running. Muscle sensor, so this one is pretty nice. So let's see a movie. So this is muscle sensors. Okay. And you see that you can detect the tension in muscle, transform it into electrical signal, and activate the robot hand. All right. Maybe let's stop it before. Alors, it was muscle sensor, then we have capacitive sensor. I'll let you just click on it after if you want. Joystick and touch screen, écran tactile. This was for the sensors. Now let's talk about digital transmission. So what's happened when you tape A on your keyboard? Okay, the A goes from the keyboard to the computer. Okay, but in fact, it's not a real A letter that will be transmitted through the wires or cables. It's going to be electrical signal, and we're going to watch it a little bit more accurate. Or it can be also wireless if you use Bluetooth. Okay, so the electrical signal is a numerical signal. So electrical is coded into numerical, okay? And you see that the value of the character, which are 0 and 1, are transmitted in a specific order. So you see that the red one, which is called the less significant bit, le bit de poids faible, has been transmitted in first. Okay, and then all the other ones have been transmitted one by one, step by step. So that's what we call a serial communication. So that means that all the bits are transmitted step by step. And by the way, encore un faux ami, un octet se dit one byte. And one byte is 8 bits. Regarding the bit rate, there are various wires, and you see that the speed, the bit rate, le débit binaire, is not always the same. So 75 bits per sequence for the RS-232, which is very low. For instance, 12 kilobits per second for the PS2, which is a little bit higher, but the USB, the last generation, you see it's much higher. It's really fast. Okay, so this is the most this is the older one, 1962. This one PS2 cable has been created by IBM in 87. And the USB has been created in the 90s, so 96 by Compaq Deck, Intel and Microsoft. By the way, RS-232 is called the serial port, le port série. C'est là où vous allez trouver comme 1, comme 2 quand vous essayez de régler votre carte Uno. Donc c'est le port série d'une liaison RS-232. Digital transmission. Do you see any 0 or 1? Of course you don't. There is no 0 or 1, really. In fact, it's all electrical signal. So you need to determine two states, 0 or 1, from an electrical signal. But how? So you will use an oscilloscope, and an oscilloscope will help you to watch the signal more accurately, plus précisément. And you have to decide what will be called a 1 and what will be called a 0. So here on this oscilloscope, we can see that we have a sensitivity of 2 volts, it's written there, by square. So that means the scale is 2 volts per square. So if I have 1, 2, 2.5, that means that I have 5 volts, okay, at maximum here. Okay, so you can then decide that the high state will be when the signal is at 5, and the low state will be when the signal is at 0 volt. So that helps you to make the difference between high state and low state. Okay, so you see, just a question of uh, which value for the electrical signal you decide to choose. So once you have your electrical signal that is coded in 0 and 1, you transmit the 0 and 1. So at the beginning, you see that when there is no data, the line is at 1. Okay, la ligne est à 1 quand vous n'avez pas de data. When you have a message, when you send the first less significant bit, then you will have a bit of start to 0 that will tell you, okay, now transmission begins. And the 1 is transmitted first. Okay, so that means the less significant bit, le bit de poids faible, est transmis en premier. And then the other one, 1, 0, 0, and so on, are all transmitted. Okay. Once it's done, you have a parity bit, but I won't talk too much about it. It's just a bit that helps you to detect if you have a mistake in the signal. And then after you have the stop bit at 1 here. So that tells you that this is end. This is the end of the transmission. On the reception, so first you will receive the less significant bit, okay? And this is a specific order, you see. So less significant bit has been transmitted in first on the right, and then you see all the other bits are transmitted one after one. Once you have received on the computer the signal, then you can translate it thanks to an ASCII table. Vous allez le traduire, vous allez traduire le code binaire en code ASCII avec la table ASCII. So you see that here you have bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, bit 7. So that fits with all these bits, except that you don't count bit number 8 here. You don't need it. It's not useful. So bit number 1, that one is here. Bit number 2, 0. Bit number 3, 0. Bit number 4, 0. So then you have to watch which line it is. So this is this line. And then for the other one, 0, 0, 1. So in fact it's 1, 0, 0, okay, because it's bit 7 in first. Here it fits with this column. So you see this column and this line. So that gives you the A letter. And that's the end. So finished. You have translate your binary data into an ASCII alphanumeric character. Okay, so now it's your turn. You need to translate the mysterious word that has been let by Snowden, Edward Snowden. So you have to read first what is in red. So it's the course that has been translated in French. So now it will be easier for you to understand. And then you have to translate the sequence, the blue line here. So sequence 1, sequence 2, sequence 3. So you have to report all the bits, the 0, the 1, and so on. Then you have to reorder it in a good way, with the less significant bit in first, and so on. And then once you have transferred it into the right order, you have to decode the byte number 1, byte number 2, byte number 3, thanks to the ASCII table. And at the end, you have a word composed of 3 letters, and you need to write it here. Okay, good luck.